All right, guys, I'm going to go through these 8 problems pretty fast. You can pause them if you need to. Okay, so first one, we're going to use substitution for all of these. I've got this equation up here that has 2 variables in it, so I can't really solve it yet. And I have this one equation down here that has 1 variable in it, so I know an answer already. So I'm going to use this information and plug it into there. If I know y equals 6, then instead of y right there, I'm going to plug in 6. So 6 equals x plus 5. Now I've got this 6 term, I've got the plus 5 term, and I've got the x term. I want to get the numbers on the same side, so I'm going to move that. I want to get the x by itself and combine those green terms. So I'm going to move this positive 5 over to the other side where it becomes negative 5. If I make my equation now, the equals comes down. The x is the only thing left on this side. And the plus 5 switched over to the other side, so 6 minus 5 is 1. All right, let's see. Does that work? If I plug it in here, I've got x equals 1. So if I plug in 1 right there, then 1 plus 5 makes y equals 6. Yeah, and that agrees because the next sentence says y equals 6 also. So my point that works is x equals 1, y equals 6. And I write that by like this, like coordinates, because the first one is x and the second one is y. And I have x equals 1, y equals 6. And I use substitution to figure it out. All right, for the second problem, let's see. Y equals x plus 12. We got 2 variables in there. And we have y equals negative 18. Well, there's a piece of information I can use. So if I know y equals negative 18, then I'm going to plug in negative 18 for the first equation where it says y, because I know what it equals. So I'm going to plug in negative 18 for y. And when I do, I usually use parentheses to let me know I plugged in something for that y. And that equals x plus 12. So I took information from the second equation and I plugged it in, or I substituted it into the first equation. Now here I've got a number term, a constant term. I have over here a constant term. And right here I've got a letter team. All right, so I want the variable all by itself. So I'm going to move this one over to the other side. And when positive 12 moves to the other side, it becomes negative 12. So I have x equals negative 18 minus 12. They're both negatives, so we can add them together to get 30, and that's negative 30. They're both negatives. Okay, so x equals negative 30 and y equals negative 18. They already told us y equals negative 18, and now we know x equals negative 30. If I plug this into this equation, negative 30 plus 12, I also get negative 18 for y, so it agrees. So I have negative 30 for x, and I have negative 18 for y. All right, let's move on to number 3. Okay, y equals negative 12. I can use that information to plug into my top equation that has 2 variables. So I'm going to take this information and plug it in to there to make one equation that only has 1 variable in it. So I have negative 12 that I'm plugging in for the y. So when I plug in, I usually use parentheses to let me know I've plugged something in. Equals x minus 10. So I substituted the second information into the first equation. Okay, same setup. I've got a number term or a constant term, and I've got one over there that has no variable in the back. And I've got this x term, this variable term. So I want the blues on the same side. I want the greens on their own side. So this negative 10 has got to switch sides and become positive 10. So it's not here anymore. So we have x on this side all by itself. And now I have negative 12 plus 10. Negative 12 plus 10 is negative 2. So I know x is negative 2. I know y is negative 12. And if I wanted to check that, even though it works, if I plugged in my -2 right there, -2 minus 10 is -12. So yeah, it works. And the way I write the answer, I don't write this like this where I say it 2 different times where x is -2 and y is -12. I write it as a coordinate, and I always put my x answer first, so -2, comma, -12. So we're good. All right, number 4. Fun one. Okay, so this one, they don't tell us what y equals right away. In the first one, we have y equals x plus 15. In the second one, I have this simple equation, y equals 2x. So I'm going to take the fact that I know y equals 2x, and I'm going to plug it into this equation. Now, could I plug in the other way? Yes, you can plug in either way, and I'll explain that later. But y equals 2x. So instead of y right there, I'm going to write 2x. That way, when I plug in 2x for that y, 2x is what I'm plugging in. I don't know exactly what it is, but I know it's 2x, 2 times whatever x is, equals x plus 15. The reason why this is better is because now it only has one variable in it, just x's. If an equation has just one variable in it, we can solve it. So it's like we took the y out and we plugged in some x's, and now all we have is x's, so we can solve this. Okay, let's make our teams. We have an x team, we have an x team, and we have a number team. So first, let's get all the teams together. This positive x needs to switch sides and get over here and become negative x. So now we only have 15 on this side. It's the only thing that we have left over here. And 2x minus 1x is just x. So we're done. It told us what x is. X is 15. All right, we know what x is, but unlike the last problem where they told us exactly what y was, we don't have a statement like that in this one. So we have to use one of these equations to use x and plug it in. We can either take this 15 and plug it in right there to figure out what y is. So 15 plus 15, and then y would equal 30. Or we can take this 15 and plug it into this equation for x and say, well, if x is 15, 2 times x, or 2 times 15, is 30. Either way, we get 30, so you can plug it into either equation, and it should give you exactly the same thing. That's what we've done. We've solved the system of equations. But anyway, now we know that x is 15, and we know y has to equal 30 because we plugged it into the equation and we figured it out. So maybe if I wanted to show my work, I could say, when I plugged it into this equation on the top, I rewrote it as y equals, and I'm plugging in 15 for x, plus 15, y equals 30. So now I have y equals 30 and x equals 15. I can write it like this. My x first and my y next. And I'm done with number 4. Okay, let's take a look at number 5. I'm sure they'll get a little tougher. Yeah, a little tougher. Okay, I have 2 equations here. I have y equals negative 2x minus 3, and I have x plus y equals 18. Now, this is a skill that you have to learn, but this first equation is already telling me what y is. It's telling me y is the same thing as 2x minus 3. They're already telling me a piece of information that if you ever see another y, you can plug in 2x minus 3 for it. So down here, I'm going to plug, instead of this y, I'm going to write 2x minus 3 because they're telling me what that 2x minus 3 is, or what y is. So I'm going to plug in x plus, and I'm going to say 2x minus 3 because I'm just plugging it in, equals 18. Now to get rid of parentheses, we have to multiply, but it's just a 1 out here, and 1 doesn't change anything. So basically, we can get rid of the parentheses just by itself. X plus 2x minus 3 equals 18. And let's see the teams that they belong in. Here's an x term. Here's an x term, positive 2x. Here's a number term. Here's a number term. So if we want things on the same team, all we got to do is move this guy over, and he becomes plus 3. Oops. Plus 3. All right, I'll make my line here. So x plus 2x, they're already on the right side. We don't have to move them. We just have to combine them because they're on the same team. X plus 2x is 3x on this side equals, and we move this guy over, 18 plus 3 is 21. Now, I don't want to know what 3x is, or 3 times x is 21. I want to know what 1x is. So if we have a 3 on top, we can put a 3 on bottom to cross it out. And we put a 3 on, but we divide by 3 on this side. X equals 7. Kind of cool. But from all that, we get a pretty simple answer. Okay, so if I know x equals 7, I can use that information and plug that into either equation for x to figure out what my y needs to be. I'm going to plug it into the top one. I'm going to use this equation up here. So now I have equation y equals 2x minus 3. But I know what x is now. X is 7. So I'm going to plug in 7 there. So y equals 2, and I'm going to put parentheses, 2 times 7 minus 3. So y equals 2 times 7 is 14, minus 3, y equals 11. So in this case, y equals 11 and x equals 7. Does that work in the other equation? The bottom equation? Let's see, x is 7 plus 11 is y. 7 plus 11 is 18. Yeah, this works for both equations. It's pretty cool. So x is 7, y is 11. We write this 7, comma 11. And we put the parentheses around the outside. 7, 11. Okay, let's see number 6. Fractions. Can we do this? Yeah, we can do this. Okay. I see y equals 1/4 x, and I see x plus 4y equals 8. Okay, since they're already telling me a piece of information, I know what y equals. Y equals x. On the bottom, it's kind of complicated. I don't know what they're trying to tell me. But on the top, I know they're telling me what y equals. So I'm going to rewrite the bottom of equation, but instead of y, I'm going to use 1/4 x. Now this one's a little complicated. I wouldn't give it you on your test just yet. So if we're going to plug in the top information into the bottom of equation, now we have x plus 4 times y, but instead of y, we're going to write 1/4 x. So instead of this y, we wrote what we know it equals. And then equals 8. Okay, this is kind of tough. First thing we're going to do is multiplication. We have to do the inside of the parentheses times the outside of the parentheses. So 4 times 1/4. Well, the good thing about this is 4 times 1/4, the 4 on the top and the 4 on the bottom cancel. Or you could just do 4 times 1 is 4 on top, and 1 times 4 on the bottom is 4. And 4 and 4 just cancel each other out. So really the 4 and the 1/4 just canceled each other out. And all we have is x plus x equals 8. The 4 times 1/4 got rid of each other. And we have an x term, we have an x term, and we have a number term. They're already on the right side. We don't have to switch teams. They're already lined up perfectly. We just got to combine these two guys. X plus x is 2x equals 8. We're going to divide by 2. So we get a 2 on top and 2 on bottom, so we can get rid of it. And we get x equals 4. Okay, so now I know x has to equal 4. But how do I figure out what y equals? I can plug it into either equation. I'm going to plug it let's plug it into the second one just because. It's really easy in the first one, but let's plug it into there. So if I know that x equals 4 on that equation, Then I have x plus 4y equals 8. But I know x equals 4, so I'm going to plug in 4 for x plus 4y equals 8. I have a number term, and a letter term, a variable term. So I got to get that positive 4 to the other side where it becomes negative 4. And now I have 4y equals 8 minus 4 is 4. I divide by 4 to get y by itself, and y equals 1. Kind of a long ways to go, huh? Kind of a lot of work for one problem. But in this equation, x is 4 in these system of equations, and y equals 1. So we write it 4 for x and 1 for y. We write it like that. Now this one will probably depress you too. But this one's going to combine a bunch of skills that we've already done. Okay, so it's telling me in the first sentence what y is equal to. Y is equal to x plus 12. They're the same thing. So in the second equation, we have 4x plus 2y equals 27. So right here, instead of y, we can put x plus 12. So 4x plus, instead of 2 times y, we're going to have 2 times x plus 12 equals 27. So 4x plus 2, let's plug in what we know for y. Instead of 2y, we're going to plug in what we know y is. 2 parentheses x plus 12 equals 27. All right, you want to see how many steps we've learned in the past that it's going to take to solve this one? Okay, so now we have an equation that has only x's in it, so we can solve this. But first thing we got to do, we see parentheses. We got to get rid of parentheses. Hopefully you see parentheses. You remember how to multiply to get rid of parentheses. We multiply the outside number times everything in the middle. So 2 times x is 2x. And 2 times 12 is 24. So we have 4x plus 2x plus 24 equals 27. Now we can start solving it because we got rid of the parentheses. We have, let's see, x term, number term. Okay, so if I want to get all the terms on the same, like separate them, the blues are already on the left. Let's make the reds on the right. So this guy's got to switch sides, and be negative 24. And then the blue guys are already on the same team. We can add those together. 4x plus 2x is 6x equals 27 minus 24 is just 3. All right, I got to divide by 6, so we get a 6 on top, a 6 on bottom. That gets rid of that. X equals 3/6. Or I can say this is 3 times 1 and 3 times 2, and the 3's get rid of each other. This is just 1/2. So x is 1/2. Okay, then how do we figure out what y is? Well, I see a really simple equation. I can just take this 1/2 for x and plug it back in here to this equation. So if x is 1/2, we say y is x plus 12, but I know x is just 1/2. So 12 plus 1/2 is just 12.5. 12 plus a little more, 12.5. So we got x is 1/2. Y is 12.5. Or we could write 25 halves, but I'm going to leave it 12.5 right now. All right, number 8. Ugh, going to be tough. Looks like the second equation is they tell me what y equals. They tell me y is equal to 2x plus 5, So up on the top one, instead of writing y right there, I'm going to write 2x plus 5, and then the top equation will only have x's. So because the bottom equation tells me exactly what one of the letters equals, I'm going to use that one to plug into the first equation. So now I have 10x plus 3, and instead of y over here, I'm going to say parentheses 2x plus 5, because that's what y equals. Equals 19. Choose a little, I'm going to go dark on here. Okay. Okay, so first thing I gotta do is get rid of the parentheses. 3 times 2x is 6x. And 3 times 5 is positive 15. I'm just gonna bring this down. 10x plus 6x plus 15 equals 19. Okay, I've got an x term plus 6x. Nope, different color. Let's go. I guess we can just go black. We got a number term and we've got a number term. All right, let's get the colors on the same side. Same team on the same side. This has got to switch and become negative 15. All right, so 19 minus 15 is just 4. This is not on this side anymore. 10x plus 6x. They're on the same team. They're on the same side. We can add those together. 10x plus 6x is 16x. We have to divide by 16. Ugh, this is getting ugly. 4/16. X equals 4/16. But we could say this is 4 times 1, and we could say this is 4 times 4. So the 4's cancel out, and this is just 1/4. Let's plug that into any of the equations. I'm going to plug it into this one. Y equals 2 times 1/4 plus 5. So y equals 2 times 1, top times top is 2, bottom times bottom is 4, 1 times 4 is 4, plus 5. All right, this was adding fractions. This is y equals 1/2, that's what 2/4 is, plus 5. Let's just say this is 5.5. Y equals 5 and 1/2. When we're just adding 5 plus 1/2, that's obviously 5.5. So this was an ugly problem. X was 1/4. Y was 5.5. Ew. Okay, last one. This one's kind of cool. Let's erase that. Okay, this one's kind of cool. Elaine bought a total of 15 shirts and pants. So I guess if shirts are S and pants are P, then we can say shirts plus pants equals 15. There's one equation, because 15 shirts, and she bought a total of 15 shirts and pairs of pants. So if you add her shirts and pants together, she has 15 things. All right, second equation is she bought 7 more shirts than pants. So pants and shirts are not equal. If we said, are pants equal to shirts? No, there's 7 more shirts than pants. So you'd have to add 7 on to pants to equal shirts. So 7 plus pants is shirts. How many of each did she buy? Okay, well, I know that if shirts is 7 plus pants, then I can plug that in for this S over there. If I know shirts is 7 plus pants, then I'm going to rewrite the equation with just P's in it. Instead of S, I'm going to write 7 plus P. That's what I just plugged in for S. Plus P equals 15. So there's just a 1 out here, basically, which when you multiply it in, just doesn't do anything. So we can just have 7 plus p equals 15. So we have, let's see, a number term, a letter, and a number term. All right, so the 7 needs to switch sides and go to -7. These two p's are on the same team and the same side. They can just combine to be 2p equals 15 minus 7 is 8. Divide by 2, divide by 2. She had 4 pairs of pants. Pants was 4. And we can plug this into either of the equations. So now 7 plus p equals s. We know p equals 4, so 7 plus 4 equals how many shirts she has. 11 is the amount of shirts. So she has 4 pants and 11 shirts. Does that work out? 15, if you add them together, do you get 15? Yep. Because she has 15 shirts and pants. 4 plus 11 is 15, yeah. Does she have 7 more shirts than pants? Yep, there's 7 more shirts than pants. All right, that's it. You're done. Turn it in.